resources will not stay idle. Okay, that means whenever you are giving a particular task, that particular task will be executed and the corresponding hardware will be stay busy. Okay, that is maintained by the operating system. Okay, now there are some other functions also which are written here. Okay, now operating system can work as a resource allocator. So what is the meaning of resource allocator? What is resource first? Resource means that memory, CPU and your IO devices. These are the resources. So these are the hardware resources, you can say. Okay. So this operating system can manage all the hardware resources, as well as it can handle the software resources like the application programs. Okay, and you see that it decides between the conflicting request for efficient and fair resource use. Okay, so efficient use and the fair resource use is actually maintained by the operating system. Now operating system is a control program. Okay, so there are two different terms. One is the resource allocator, where it is handling the different hardware resources and the software resources, managing that one with the user application programs. And then it is working as a control program. So control program means that it controls the execution of different programs to prevent errors and improper use of the computer. That means suppose someone is trying to access your computer without permission and trying to hack the computer by using unauthorized password, then that will also be checked by the operating system. The operating system will not allow any unauthorized person to make a particular change or anything else, or steal data from your computer also. That is also be hidden. Okay, so this operating system will perform the task, that is it will prevent the different types of errors as well as different improper use of the computer. Next, so what is the definition? Definition is already told to you. That definition of the operating system is that it is a particular program that will stay in between the computer user and the computer hardware, where the computer user will give some instruction to the operating system. It will accept that from the user, and then it will pass the particular instruction to its corresponding hardware. Okay, where by using which hardware the user is actually trying to work. Okay, so the operating system will decide that one, that which hardware will print something, which hardware will display something, which hardware will take input from the user. Okay, that will be decided by the operating system to give the instruction to the particular computer hardware. Okay, so when your computer start up, at that time what happens? Basically, a program is there called the bootstrap. This bootstrap will be loaded at power up, when your power is actually you're giving your computer to power. I mean the reboot, I mean when you're booting the computer. Okay, that is actually loaded. So this bootstrap program is stored in the ROM. Okay, or you can say EPROM, that is electronically programmable read-only memory. And this EPROM is generally a firmware, kind of firmware. Wait, someone is trying to join. I think you should join early so that we can continue the class without any disturbance. Okay, now this initializes all aspect of the system and loads operating system kernel and start execution. So operating system kernel means kernel is the code of the operating system. Okay, as we have Suppose in our body, what is the core? We can say the heart is the core of our body, okay, of the human body. Like that, operating kernel is the core of the operating system. Means kernel is a separate part where the kernel can execute some programs. Okay, so operating system own program will be executed by the kernel, and the user program will be the separate programs. Okay, so user programs will be in one side, kernel program will be in another side, and the other program and the rest of the program will be for the other works or for the future use. Okay, so these different divisions are there. Okay, now you see that in a computer system, in a view, if you see the view of the computer system, then we can see that CPU is the processing device, disk controller is controlling the disk, means the hard disk. Okay, that is your storage. Okay, that is your permanent storage. And then the USB controller is there, that is controlling different IO devices like your mouse, keyboard, printer, etc. Graphics adapter is there, that is connected there. You know that VGA cable is available there. Okay, so VGA cable is there, and the I mean HDMI cable. Okay, so that cables are there that will actually connect the graphics devices like your monitor. Okay, monitor will be connected by using the graphics adapter, and all are connected with the memory. Means anyone can give direct input to the memory, then someone can take data from hard disk to the memory. Means what is difference between disk and memory? You see, disk means the permanent storage, okay, like your hard disk, and memory means that your main memory like RAM. Okay, so anyone, this CPU can access memory, hard disk can access memory, these IO devices can access memory, and monitor can access memory. Okay, and all is connected with the memory. So memory is actually taking the so memory is a common here, and other devices are the separate components here. Okay, now computer system operation, we can see that IO devices and the CPU can execute concurrently. What is that? Concurrently means what? That together, okay, or parallelly. So if we give any input from the input devices, then that will be taken by the CPU. Also, when the CPU will give some output to display to the user, then also that will be displayed in the output device. So concurrently they can work together and execute some some of the programs. Okay, then each device controller is in charge of a particular device type. Now what is the device controller? Means if you want to use your printer, then printer device controller will be there. If you want to use a mouse, then mouse device controller will be there. If you want to use a keyboard, then keyboard device controller will be there. So each and every device controller is there. That device controller is like device driver. They have their own task to perform and to manage the particular device. Each device controller has a local buffer. Now what is buffer? Buffer is a temporary storage area. For every device controller has a temporary storage area, that is a local buffer, where the requests are kept. Then CPU moves data from or to main memory or to or from local buffers. Now see that when the CPU is actually working with a particular data to store in the main memory or fetching some data from the main memory, so both are possible. Means both way direction, from the CPU to main memory and from main memory to CPU. Okay, CPU can take something from the main memory or CPU can store something in the main memory. Okay, now what is happening here, when CPU is working with a particular main memory location and it is giving some instruction or data to store in the main memory, at that time if another instruction is coming, then that will be stored in the local buffer, and when it is completed, when the previous instruction or data is kept in the main memory, then from the local buffer the data will be captured by the CPU and it will store that one in the next memory location. Okay, so the memory location may not be contiguous, may be some random location also. Okay, because it is a RAM, so RAM is actually following the concept of the random memory, random access memory. Okay, so it may not be happen that when a CPU access a particular main memory location, then the next main memory location will be the next contiguous location. This will not happen. Now IO device is from the device, so IO is the device to local buffer of the controller. Okay, so IO device means that every IO device has a local buffer. Okay, and the local device controller also. So this device controller will give instruction or take the charge of the IO devices, how they will work and what is the program running there. Everything will be in the charge of the local IO controller. Okay, device controller informs the CPU that it has finished its operation by causing an interrupt. Means this may happen that when you know that there is a particular operation called the DMA operation, direct memory access. So when direct memory access is required, then DMA controller is present that will request the CPU to relinquish its buses. Okay, to release its buses, that so that the DMA controller can directly operate with the particular devices. Okay, and the memory device. Okay, so this thing happens, and at that time what will happen that when the CPU actually relinquishes buses, it will give an